Hello, and welcome to the Calvert Hall College High School Aerocards Flight Readiness Review. In this video, we plan to give a brief overview of our team as well as our system design capabilities. Matt Minogue, Team Leader, Junior. Braden Wolf, Ground Control Station Lead and Safety Pilot, Sophomore. John Wynn, Mechanical and Deliverable Teams, Sophomore. Will Bauer, Programmer, Freshman. Patrick Katulik, Team Manager, Sophomore. Dan Zimmerman, Communications Lead, Senior. Robbie Stewart, Video Lead, Freshman. Brian Schwartz, Mechanical Team, Freshman. The Callimpri is divided into three sections: the flight module, the propulsion module, and the payload module. Inside and on the top of the central part is the airframe that contains the flight controller, a Pixhawk 4, the GPS, the radios, and the power regulator, which controls the power output from the battery to ensure the chance of accidental overdraw in the battery is minimal. The propulsion module is on the ends of the struts extending from the airframe and consists of the newer and more reliable ESCs and motors that allow the system to fly. Finally, there is the payload module where the gimbal and air delivery are located. This year, we will be using two computers in our ground station. One computer will be running Mission Planner, a very powerful system capable of running the entire UAS for autonomous flight. We will have an additional computer for object detection, classification, and localization. The two devices will be connected via Ethernet in order to communicate the drone telemetry and find the location at the time of each picture for localization. For our drop mechanism, a servo will react and drop the water bottle that was attached to a servo bar, which will fall and reach a terminal velocity at 42 meters. Due to a sharp increase in our programming capabilities, we have been able to create a program that can autonomously transmit telemetry data from the drone to the interoperability server. Due to advancements this year in team capability and knowledge, our final product will be much more capable of completing each aspect of the competition requirements with more accuracy, reliability, and safety. For our air delivery system, we have very high confidence. Our tested autonomous flights all demonstrated the high accuracy of our UAS when flying a waypoint sequence. We have also proven the system to have a high versatility of flight capabilities, including speed, maneuverability, and acceleration. Our developmental testing consisted of conducting test flights to evaluate the system's performance, as well as conducting component tests to calibrate our sensor readings. On our 8 autonomous flights, the Callimpri achieved 100% waypoint accuracy, with an average error of 1.2 meters. During each flight, the entire time was conducted autonomously, accumulating around 2 hours of flight time. Last year's mission demonstration proved that the GoPro Hero 4 was more than capable of resolving the targets from a height of nearly 120 feet. With a little bit of trigonometry, the team proved that a lens angle between 30 and 45 degrees on a camera with a 1080 pixel by 1920 pixel resolution will be more than sufficient to resolve a target less than 1 foot wide. The imaging algorithms are under near constant revision. While we do not have exact statistics for its current performance, I would estimate that it can accurately identify about half of the targets. The localization algorithms are also under near constant revision, but preliminary tests have revealed that the highest error has been around 124 feet. which corresponds to a minimum 0.17 points per target. While it is far from optimized, the initial results are promising. The final iteration of the new airdrop mechanism has just recently been completed. It is capable of reliably dropping the 8-ounce water bottle, which has broken on impact all but one time. Due to a tight schedule and a recent component failure, we have been unable to conduct a full mission test this week. Our next mission test is scheduled for Wednesday, May 30th. Given the data from individual tasks, developmental testing, and prior experience, the team is confident that our system will perform as expected and that the team is prepared for the upcoming competition. Based on the developmental testing of our current configuration, the team expects to be able to score a minimum of 49 to 55% of the possible points allotted for the mission demonstration. The Aerocards have spent the last few months in intense preparation, working through setbacks and failures to find better solutions. With these improvements to our system design, the team is confident that we will be able to increase our score and demonstrate an overall improvement.